Welcome back, students. So in last class we discussed about the pressure exerted by liquids. In the same way, gases also exerts pressure. Gases also exerts pressure, or we will say pressure exerted by the gases. Pressure exerted by the gases or pressure exerted by the air due to its weight. The pressure exerted by the air due to its weight is known as atmospheric pressure. Last video we discussed about liquid pressure. Here atmospheric pressure means pressure exerted by the air due to its weight. That is known as atmospheric pressure. So, when you inflate a balloon, the air will exert pressure on the walls of the balloon, means inner walls of the balloon. When you inflate a balloon, the air will exert pressure on the inner walls of the balloon. Means gases also exerts pressure on the walls of their container. Gases also exerts pressure on the walls of the container. Example, when you inflate a balloon, the air will exert pressure on the inner walls of the balloon. That is, gases also exert pressure on the walls of the container in which they are kept or in which they are taken. Then atmospheric pressure means the pressure exerted by the air due to its weight. That is known as atmospheric pressure. That is given in your textbook, page number 140. Atmospheric pressure. We know that air is all around us. The envelope of air around the earth is known as atmosphere. The atmospheric air or the atmosphere extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. The pressure exerted by the air due to its weight, that is known as atmospheric pressure. We know that pressure is force by unit area. If you imagine a unit area and is very long cylinder standing on it filled with air, then the weight of the air in this cylinder is equal to the atmospheric pressure. So, atmospheric pressure means the pressure exerted by the air due to its weight. That is known as atmospheric pressure. So, atmospheric pressure is the weight of the air in a column of unit area. If you consider a unit area means 1 centimeter length, 1 centimeter breadth. Then if you consider a square of 1 centimeter, then what is the pressure exerted by the air on that unit area? Okay, what is the force exerted by the air on that unit area? That is known as atmospheric pressure and it is due to its weight. Now, so many examples are there. Gases exert same pressure on the walls of the container in all directions. Our example extends to several kilometers above the sea level. The weight of air acts as pressure known as atmospheric pressure. Still here, atmosphere will exert pressure on our body. Atmosphere will exert pressure on our body, but we do not feel the pressure exerted by the atmosphere. We do not feel the pressure exerted by the atmosphere. The reason is that the blood and other fluid in our body, the blood and other fluids in our body will exert a pressure and that pressure will be equal to the atmospheric pressure. Okay. The pressure in our body balances the atmospheric pressure. That is why we do not feel it. We are not feeling it. We don't feel the atmospheric pressure because that atmospheric pressure is balanced out by the pressure exerted by our body. That is mainly due to the blood pressure and the other fluids in our body. Okay. So, we don't feel the atmospheric pressure. Now, this is an experiment to prove that air exerts pressure. It is an experiment to prove that air exerts pressure. So, what you have to do is that in two methods you can do this activity. If you are taking a plastic bottle, put some boiling water in it. Take a plastic bottle, put some boiling water in it. The steam coming out of the water will expel most of the air from the inside the bottle. When you fill water in that bottle, boiled water in that plastic bottle, steam will be coming out from the bottle. That means most of the air in this air is replaced by the steam. Air inside the bottle is replaced by steam. After 2 minutes, tight the cap of the bottle and put the bottle in a basin or in a bucket and pour some cold water mixed with ice on it. So, first you have to take a plastic bottle, then fill it with a boiling water. So, when steam comes out from the bottle means that the air is replaced by steam. Air inside the bottle is replaced by steam. So, after 2 minutes, tighten the cap, then put this bottle in a bucket and pour some cold water mixed with ice on it. Pour some cold water mixed with ice on it. So, you can see that when you pour cold water, the shape of that bottle will change or the bottle will be crushed. The bottle will be crushed. The reason is that when we pour cold water onward this can, the steam will be converted to water. Condensation will take place. Steam, water vapor will be converted to water. So, condensation will take place and the air has and the bottle has very little air inside it. And the bottle has very little air inside it. That means inside pressure is very less. The pressure inside the bottle is less. Pressure inside the bottle is less, but the pressure outside the bottle is greater and the bottle will get crushed. And the bottle will get crushed. That is the activity. So, here I have taken a metal can. So, you can heat it. Heat the can. First, you have to take the metal can, fill it with water, then you heat the can and the water will start boiling. Wait 5 minutes so that the air inside the bottle is replaced by the steam. So, let it boil for 5 minutes. After that, you tighten the cap and then you pour cold water. So, inside the bottle steam is there. When you pour cold water, that steam will be converted to water. That is, condensation will take place and inside the bottle the pressure will be very less. Inside the bottle the pressure will be very less, but outside the pressure will be more. Outside pressure will be more, inside pressure will be less. That means the atmospheric pressure acting on the bottle from outside is much larger than the pressure exerted by the air inside it. The atmospheric pressure acting on the bottle from outside is much greater than the pressure exerted by the air inside it. So, inside air pressure is less and outside pressure is more, and that bottle will get crushed. So, all this one is an activity about atmospheric pressure. How to demonstrate this atmospheric pressure? Application is there. Here this bottle will be crushed from all sides. The bottle gets crushed from all sides. That means that air pressure acts equally in all directions, or the pressure exerted by the air acts equally in all directions. Okay. Then applications is there. Mountaineers suffer nose bleeding at higher altitudes. Mountaineers suffer nose bleeding at high altitudes. So, high altitudes means maximum value of atmospheric pressure is at the sea level. Maximum value of atmospheric pressure is at sea level. As you go higher in altitudes, the pressure exerted will be low. The pressure exerted by the atmosphere will be low, or at high altitudes atmospheric pressure will be less. Okay. Or in other words, we will say it like this: atmospheric pressure is maximum at the sea level. As we go to higher altitudes, the air becomes thinner and the atmospheric pressure decreases. So, maximum value is at sea level. As we go to higher altitudes, the air will become very thinner and the atmospheric pressure will reduce or decreases. Okay. That is the reason for nose bleeding at higher altitudes. Nose bleeding at low pressure means outside pressure will be low. Now, mountaineers suffer nose bleeding in high altitudes. High altitudes atmospheric pressure decreases. So, outside our body pressure is low. Inside our body, that is our body pressure, that is mainly due to the blood and other fluids in our body. That is mainly due to the blood and other fluids in our body. So, our body pressure is more and outside atmospheric pressure is less. So, what will happen is that the small blood vessels in the nose will rupture or will burst. The small very fine blood vessels in the nose will burst, and that leads to nose bleeding. So, the pressure exerted by our body will be much greater than the atmospheric pressure at high altitudes. The pressure exerted by our body is much greater than the atmospheric pressure at high altitudes. This may cause the blood vessels to burst, and that results in nose bleeding. This may cause the blood vessels to burst, and that may leads to nose bleeding. Then inside the aeroplane, normal atmospheric pressure is maintained in order to avoid all these problems. Okay. Since they are flying at very high altitudes, outside pressure will be very less. So, inside an aeroplane, normal atmospheric pressure is maintained in order to avoid all these issues. Then astronauts wear special space suit which maintains the normal atmospheric pressure for their body. Astronauts normally wear special space suit. So that suit will provide necessary atmospheric pressure for their body, since there is no atmosphere at the outer space. Since there is no atmosphere outside the earth or outer space, there is no atmosphere. So that space suit will provide the necessary atmospheric pressure for their body. That is normal atmospheric pressure for their body. All these are examples of atmospheric pressure. Okay. So, when you drink juice using a straw, when you drink juice using a straw, when you suck the air into our mouth, the air pressure inside the straw is reduced. When you suck the air through the straw, air pressure inside the straw will be reduced. But normal atmospheric pressure will be acting on the juice, on the surface of the juice. Normal atmospheric pressure will be there on the surface of this juice. So, this atmospheric pressure will push the fruit juice to get into the straw. So, when you suck air through the straw, inside the straw, the pressure will be less. Atmospheric pressure will be acting on the surface of this fruit juice, and this pressure will push the fruit juice to go into the or get into the straw. That atmospheric pressure will push the fruit juice to get into the straw. And we will be able to drink juice. That is, when you suck the air through a straw, the pressure of the air inside the straw is reduced, but the pressure acting on the surface of the juice is equal to the atmospheric pressure, and this atmospheric pressure will push the juice into the straw to our mouth. So, that greater atmospheric pressure will push the fruit juice into the straw and it will get into our mouth. The same thing in case of syringe also. Okay, this one is a piston of the syringe. When you release the piston or when you push it upward, air pressure inside that piston will, pressure inside this region will be low. This region, the air pressure inside this region will be low. The pressure acting on the fluid surface is equal to the atmospheric pressure, and that pressure is greater than the pressure inside this portion. Okay. The pressure exerted on the fluid or on the medicine is greater than the pressure inside this piston. Then this fluid will get into the syringe. That fluid will get into the syringe. When the nozzle of the syringe is dipped in a liquid and its piston is downward, withdrawn or moved in the upward direction, the pressure inside the syringe is lowered. The pressure inside the syringe is lowered. The greater atmospheric pressure acting on the surface of the liquid pushes the liquid up into the syringe. The greater atmospheric pressure acting on the surface of the liquid pushes the liquid to get into the syringe. Then the same way is about rubber suction pad. Normally we use that one to hold the calendars and clothes on a smooth wall. So, when you fix that suction pad on the smooth wall, inside this portion is low pressure. Inside air will be removed from this portion, means inside the portion it's low pressure and outside here it's high pressure. Here inside this portion, inside the space between the wall and that suction is low pressure, and outside that it is atmospheric pressure. Atmospheric pressure is greater than the inside pressure, and the suction will attach firmly in the smooth wall. Rubber suction pad is pressed against a smooth plane surface. The air between the suction pad and the wall is removed, and the pressure inside it will be less. The outer atmospheric pressure is greater, and that pad will be firmly attached to the surface of the wall. So, all these are about applications of atmospheric pressure. So, atmospheric pressure means it is a pressure exerted by the air due to its weight. That is known as atmospheric pressure. The maximum value is at sea level. As we go at high altitudes or as we go high altitudes, the pressure will decrease. Okay. So, that is about atmospheric pressure. Thank you.